So I was just talking to Miss Crump about this, that back in like fifth grade and fourth grade, you guys remember that plus and minus when you first learned it was really easy, right? And then someone introduced you to times and your mind was blown and you were like, oh my God, times is so hard. And then somewhere around sixth or seventh grade, when you start learning about fractions is the first time it happens to you, suddenly plus and minus become a lot harder. Times and divide, as you know from that quiz yesterday, they're just reducing stuff. It's all times and divide has ever been is just reduce stuff. But plus and minus are a lot harder. You guys remember why? When we're talking about fractions, why are plus and minus like a trillion times harder? Because you have to make sure the denominators are the same. And so that's what we're doing today. And probably like Monday and Tuesday, I'm guessing it'll take a few days. The typical learn it today, work Monday kind of thing. So this will eat up. This probably will be the last quiz that we work towards, but I can't say that for sure. But we're doing what we did before with rational expressions, but we're adding and subtracting now. So this will be um, more challenging, just for like I said, or like Morgan said, because the denominators now we have to worry about them. Times and divide feel really just chaotic, not chaotic, but just I don't know, man. You just factor stuff and cancel stuff out. Like, um, yeah, this is a little different. So. How long will this take? I have no idea. But first, I guess I'm going to just throw a problem in. I'm going to call an audible on myself here and throw in a problem that wasn't on my note card. I thought about this and I thought sitting here looking at you now, I realize I should have added this just so we're all perfectly clear. So if I had like, I don't know, like 5 minus 3x over 4 minus 3 plus 2x over 4. So why do we kind of sort of like this problem? So this is a stress-free kind of thing where I just, the bottoms are already the same, which won't be the case. I think I have one example scripted here where they're the same. But I've really got to be aware of the fact that if the bottoms are the same, I can just go. It's just green light time, right? So what's going to happen is I'm going to have an answer whose bottom I already know is 4. The thing about denominators is if they're already the same, then your answer is going to have the same denominator, right? It's no different than in like sixth grade or something. If you did like 1/8 plus 3/8, the answer is going to be some amount of eighths, and then you just add the tops together and reduce, right? So that's just all we're doing. We're just doing it on a more high schooly level. So the thing you have to be cautious for, and I did make sure to throw like a hefty sprinkle of this throughout the lesson, is that this minus, and it's hard to say this right now because like we're a week away probably from your next quiz, but that minus will be 100% what separates like the A's on the next quiz from like the C's. And that one thing, and the reason for it is because what a lot of people see this as is they see this top. So if I were to look at the top like this, a lot of people just see it as 5 minus 3x minus 3 plus 2x. And if you see it like that, then it's a good thing we're talking about this because that minus isn't on the 3. That minus is on the entire second fraction, right? So the minus doesn't just belong to the 3. He belongs to everybody on the top of the second fraction. So if I wanted to fix what I wrote up here above the funny bubble, I would have to put parentheses around the 3 plus 2x. And you don't have to worry about that if the yellow thing is a plus, but when it's a minus, you can just, that'll be the thing. That will, once we get all the LCD stuff down and we know how to multiply and change stuff, that will continue to be the thorn in the side is the minus that we forget to distribute. So what this really becomes now is, yeah, 5 minus 3x, but then minus 3, and then what's after that? So you see, it's actually a minus 2x, right? So he gets anything in the second fraction is going to get affected by the minus if I put a minus there, or if anyone puts a minus there. And then you would combine your like terms. And so in this case, I would get negative 5x's, and then 5 minus 3 is 2. And I would just stick that over 4 and be done. You will see instances on occasion where you'll be able to factor the top. or maybe the bottom, and find common factors. So we'll still kind of think about the things we've already learned. But in a case like this, it's obviously done because you can't pull anything out of the top. 4 doesn't reduce with both items in the top. And you would be inclined at some point to ask the question, well, can't I reduce the 2 and the 4? And we have to continue to stay strong. And remember, not kill any kitties and say, I am not going to reduce the 2 and the 4 because the 2 is not a free range multiply 2, right? He's not cancelable. He's part of a plus. So what we have here would be our final answer. Good. All right. So let's look into some problems now. Like, what does this look like when the denominators are not the same? So for example, if we had 7 over 2x's minus 5 over 8x. So for the first time, we're going to have the conversation about what is the LCD. That will be our hot topic for the next several days. What's the LCD? And I would just ask you first if you know. Does anyone know what the least common denominator of 2x and 8x is? It's 8x. And so what you have to think about is, can I come up with a denominator that both of the other denominators can be built out of? Right. So some people might say, well, it's 2x, but then I'd challenge you and say, well, you can't build an 8x out of a 2x. And so we would look at this and say, the denominator that I need to be common to them both is already one of the denominators. That won't always be the case. But in this case, 8x is fine. So I like to go off to the side, and you'll probably get into this habit and write LCD equals. It becomes a little bit more complex as we go. So in this case, the least common denominator is 8x. So as has always been the case, again, since like 5th or 6th grade, is if I'm going to do an addition or a subtraction problem, I have to make sure the denominators are the same. So in this case, I'm going to take only one of the fractions, this first one. And what do I need to multiply its top and its bottom by to make its bottom happy? Or just 4. So we're going to take this top times 4 and this bottom times 4. As is often the case, you don't have to multiply them both. Like there's no law that says I have to change both fractions. If one of them's already got the LCD, then leave them alone. So what does my new first fraction become? 28 over 8x. And then the minus 5 over 8x just stays the same. And now that the bottoms have been made to be the same, we just write our answer and say, okay, I know my answer is going to have 8x on the bottom. And then I just subtract or add, whatever the case may be, the tops. What's 28 minus 5? Okay, that went well, 23. And then I look at the numbers and I ask myself again, as always, can I reduce? And in this case, no, we missed it by a little bit, right? If that 5 had been a 4, then we could have had 24 over 8x. And just like we learned in the last unit, we could reduce it down. But this one's dead. Game over. Problem over. Good. Let's do another simple one. I'll let you know when we transition to the different level, because when you do our next assignment's on Delta Math, and it will be level 1 and level 2. So we're going to kind of just loiter around in level 1 here for the first 5 or 10 minutes. So how about 4 over 7, 4/7, plus 6 over 7x? Again, what we have to think about is what denominator is common to them both. What do you think? You would, but you really didn't answer my question. So the question I'm going to keep asking on every problem that I really want you to answer for me, it's not rhetorical. Thank you, is what is the LCD? Because we have to we got to get that vision and keep that vision. What is the least common denominator? In other words, what can both of these denominators turn into? And I just look at it and I think of it the way Parker did. And I say, well, 7x is common, which means that I only have to multiply the first fraction, his top and his bottom, by x. The objective being, I don't care what happens to the top. I'm just making sure that the bottoms can match. And then once I'm done with that step, what's 4x, or 4 times x is 4x, right? So we have 4x now over 7x plus 6 over 7x. And I've had people before, so don't be the person that does this, because we probably will make fun of you, who've asked, can I cross out those x's? So don't be that kid, right? Because that would be really, but what's the point, right? We put them there, like we want them there. So if you see a fraction and you think, ooh, I can reduce it, Well, you probably don't want to because it's probably unreduced because you made it that way so that it could, fulfill an objective. So now that we made the bottoms the same, our top is going to be 4x plus 6, and our bottom is going to be 7x. And that's done. Okay, but I want to show you how close we came to it not being done. So maybe this is a little bit of foreshadowing, but if I'd wanted this to be a little bit more of a challenge problem, then going back to the beginning, I would have written it maybe as something like 4 over 6 plus 6 over 6x. And it's a kind of a silly question, really, what I'm asking you. But the point is, like, look at if we multiplied, again, you would agree the LCD is 6x. And if we multiplied them both by x, then we would get 4x plus 6 over 6x. And you can see we were really delicately close to this because what can I pull out of the top? A 2. And if I wrote the top as 2 times 2x plus 3, then you would identify that the bottom is 2 times 3x. And so you see, again, we were really on the precipice of having something that would enable us to reduce the answer down. But it's kind of a side note. I'm just showing you that you gotta look out at the end and say, can I factor GCF or whatever I can do to maybe expose a common factor from the top and the bottom? Just be vigilant about that. Okay. Again, warm-up problem. How about this one? 5x over 6 minus 4x over 3. I'll ask you the question, what's the LCD? Yeah, we all agree. If you're struggling with understanding like the least common denominator of 3 and 6 is 6, you're not cooked. I mean, you will be if you don't do anything about it in the next few days, but just come and see me if you're uncomfortable with just the basic idea of a common denominator, okay? I'll help you out. So once we identify that they can both be made into sixes, yet again, I see that I don't have to modify the first one. I merely have to multiply the second one by 2, his top and his bottom. Okay. And so we wind up with 5x over 6 minus 8x over 6. Everybody okay? And then we know the answer. We can tell it's going to be over 6, right? And then just add the tops together. What's 5x minus 8x? And good. Feel good about that answer? Right. And so you should hate this answer. Like it's not wrong yet. It would be wrong if I hit full send. I type this into Delta Math or put a box around it on a paper assignment, then I'm done for, right? Because you realize now, bless you, that this 3 and this 6, of course, just like they always could be, they could be reduced, right? Divide them both by 3. What would we wind up with in this case? Negative x over 2. Mhm. Divide them both by 3. You're fine. Okay. Let's do one more warm up and then I'm going to jump us up to level 2. Level 1, you're going to find they already have the same denominator, or they're going to be simple denominator conversions like a few that we just did. So this is nice because the bottoms are the same, but really the purpose of this example is I want to verify that you learned something from that very first thing we talked about. So what's the red flag here?
The bottoms.
What's the what's the red flag in this problem? Yeah, like you've come to in math, you learn like when we got to the equations that had square roots on both sides and then an extra number, that became our red flag. Those became the square, square, multiply, double demon problems, right? Um, there's something about this that I want you to train into yourself is like and this will go into your page of notes. You start your page of notes today. I don't care tomorrow, whatever, but something about this problem is evil. Do you see it? It's going to get you. No, it's this. And again, I'm just going to keep warning you about this, that if I give you two fractions like this and there's multiple pieces on the top of the second, you have got to somehow get trained into yourself that you need to be on the lookout for that guy. He is pure evil. His intentions are evil. He spends his entire life just trying to make high school juniors miss math problems. Okay. So I'm going to rewrite this. I already know my answer is going to be over 3x plus 4. Because, of course, when you add two fractions and the bottoms are the same, then the bottom is just going to be the same as that, right? So I'm going to rewrite the top. Basically, this entire like purple, whatever this thing is, I'm going to rewrite it with you. I'm not going to do really much math here. I'm just going to copy some stuff down. So here we go. Negative 8x minus 6. And then what? Plus 14x. Watch out.
So how can we distribute that?
Mhm.
Don't distribute it bottom.
Because if you did, then it wouldn't really be a negative anymore. Because if you distribute a negative to the top of a fraction and you also distribute it to the bottom of a fraction, then you're really taking one negative sign and cloning it, and then the two negatives would go away and become positives, and it would not make sense, right? So there will come times when we get to the advanced level next week where we start looking at where should the negative go. It will sometimes make more sense to put it in the bottom, you'll see, but that's not today. So it's just a single minus, okay? Otherwise it would go away. Everyone see that both of these signs with the red arrows pointing at them changed, right? Because of the distribution. And now let's simplify this a little bit. So what are we going to get on the top? 6x's and plus 8. And are we cool with this answer? So again, this doesn't always bear fruit. I always say like you should always go check the trees. It's not to say that you're always going to get a piece of fruit, but to not check, then you won't ever know. And so in a problem like this, if I take this and I GCF out a 2, I get some fruit because what's left when I pull out a 2? Plus. And we just spent an entire week in this class practicing problems just like this. It's not the 3x that cancels the 3x, and it's not the 4 that cancels the 4. This entire 3x plus 4 cancels this entire because they are the F word. They are factors now. They are not. What were you thinking of the other F word?
There's a lot of other F words I was thinking.
Oh, fact. I was thinking of factor. So the 3x plus 4s, one that we had to expose ourselves, cancels the other. What's our final answer? 2. Okay. Good, good. All right, let's head up to level 2. So there's your warm up. Nothing to it. I rarely, I do this all the time, every year, same time, same place. I rarely get this question answered correctly on the first try. So it's not gonna stop me from trying because I'm curious. Maybe someone will say the right thing. You have any idea what the least common denominator is? It's a gnarly question. The hard part about this is that you guys see this as an X and you see this as a 2. And that's the thing I have to try to coach out of you is that is not an X and that is not a 2. This is an X plus 2. It is a thing. They are not separated entities. X plus 2 is an item. And the exact same logic then would dictate that X minus 3 is not an X and a 3. It's a thing, right? So maybe if I put it in parentheses like that, might that clarify a little bit? Do you want to take a shot at the LCD now? Nope. You're going to hate this answer, by the way. Sorry. Did you say that again?
Would it be?
It is. The least common denominator is I need one of those and I need one of those. And so for the first time, we see a common denominator that's not very seventh grade-y, right? We probably didn't struggle with 4x and 8x going, oh, I need to make them both 8x or something like that. But this is not very visual. You've really got to get your head around the fact that the x's and 2's and x's and 3's, they're not free range move about the cabin entities. X plus 2 is a package deal. X minus 3 is a package deal. Each of them is his own factor. Having said that, I then acknowledge that I just need one of each. And once I understand that, then I start going through the question of, well, okay, I need to change each fraction to make sure that his bottom matches what Jackson gave us in the upper right-hand corner of the TV. So having said that, what does the first fraction's bottom need? So the 3 is going to be multiplied by x minus 3. And of course, so is the bottom. What you'll find soon here within the next few minutes is I'll stop writing my work on the bottom because like we all know after a while, like why we're doing this, right? So I don't always show what I'm multiplying by on the bottom, but I'm sure going to show it on the top. And what does the second fraction's bottom need? It needs an x plus 2. And again, of course, so does his bottom. Okay. Now, the one thing I'm going to do is I'm going to add something in purple, and I think you should do this as well. This is for you, for your help. You should parenthesize this top, just because it's going to remind us to give a little respect to the purple and yellow on the top right. We need to remember now that the x plus 2 isn't multiplying by the 5 or the x, it's the whole thing. That's gnarly. That's a big jump for you there. So here's what our answer is going to look like so far. And it's not done, but we know the bottom is going to say x minus 3 times x plus 2. And now we're just going to attack some individual math problems. The first one is in green. What is the answer to the green math problem? Correct. And on the next one, I'm going to circle in white. And because this is a plus sign, we're good. This will be a cruiser. What we're about to do would be a little bit tougher if it were a minus, but all we have to do now is just consider the white oval. And don't say some rookie garbage like x squared plus 10. That ship should have sailed months ago. What is x plus 5 times x plus 2? Yes. I love it when you say stuff like that. Seriously, yeah, that's worth a double fist pump, right? Remember, it never stops being a thing. A binomial times a binomial, you got to multiply the whole thing out, right? Give it some love. Great job on that one, Parker. And then from here, let's just clean up the top and see maybe if we can find a piece of fruit. I'd say often you're not going to, but let's just make sure. So the top, yeah, when I clean it, is going to be x squared, of course, goes first. How many x's will we have? 10x, so plus 10x. And what will the c, the constant term, be? The only way that this problem is not over is if the top could be factored so that I could expose a common factor. The top right now is just one big thing, right? You get that? So like I can't look at it and try to like pick and choose what I want to cancel. You understand that? Now, if I had done the bottom and it had just like coincidentally come out to be something like, say the top, just a pure hypothetical, had been like x squared minus 4, right? You get that? That could happen, right? And then if I factored it, I'd realize, oh, snap, the top is actually x plus 2, x minus 2. And then you would see that there's a piece of fruit that you could grab, correct? Okay. I'm going to see whatever this is all about. We're going to get on to the next example. Long story short, this is your final answer in this case. Okay. So quite a leap, right? Compared to think about what we were doing 10 minutes ago, and now they're starting to get pretty legit here. So just, again, just for my curiosity, I like to ask, anyone have thoughts? Why?
Because you could multiply by x minus 5, the top and the bottom.
You're pretty amazing. Yeah, yeah. Sometimes you drive me a little nuts, but most of the time I just say, man, you're your brain and math. They're like bedmates. Yeah. So what I'm going to tell you guys is kind of a slowed down version of what Parker just tried to tell us, and that is that when you see something like this in expert level, man, you want to factor. Okay. And the reason for that is what you're doing when you factor is you're exposing pieces. And so I don't look at that second denominator as what it is. I look at it, and Parker did as well. I look at it as x plus 8 times x minus 5. Factoring, I mean, it just continues to rear its head, right? It just never goes away. So now if I take this old denominator out and I see the problem in its true form like this, then our brains all go to where Parker's went. And maybe some of yours went there as well. If so, nice job. So we identified that the least common denominator now is I need one of these. But for the second one, I also need one of these. Your denominator that's common should contain all the pieces that are required to build all the denominators. Right. So again, yeah, just kind of repeating all the stuff that Parker already said. I look at it and I say, okay, what is the first fraction's bottom missing? The x minus 5. What is the second fraction's bottom missing? What's the second fraction's bottom missing? Nothing. So like we see sometimes again, I don't have to change both fractions if one of the denominators is already the common one. Okay. Great job on that, by the way. So when I do this math problem right here, what do I get? The thing in the yellow oval.
3x minus 15.
Nice. And let's see if you've been paying attention. When I do the math problem in the red oval, what do I get? Good for you. Yeah, first test has been passed, right? So you saw it. You saw the demon minus in the middle and remembered to distribute him to everybody in the top, right? Everybody gets affected. And then what is my bottom going to be? Well, this. And a question that I get a lot of times is, do you want me to multiply the bottom back out? And my answer is 100% of the time, absolutely not. I don't know why you'd want to do that. I mean, if anything, leave it like that because maybe we'll find something on the top. Usually we don't, but if we were to, and then we had to refactor the bottom, well, that would be silly. So just leave everything factored. That's okay. The only law that you could break here to get these wrong would be, of course, well, if you factor wrong, but beyond that, if you didn't see something that was common, then of course, you miss it. So leave your parts and pieces out. Don't put it all back together. What does my top equal? And I look at that and I think there's no way I'm going to factor u, so I'm just going to copy this down, make it official, and move on to the next problem, right? So there's no flags there at all. Again, if you're really paying attention, I'm going to draw a purple arrow to a number. This is a big brain question. If I were like when I write your tests and quizzes and practice quizzes, I reverse engineer a lot of problems to make things happen at the end. What number would I want to reverse engineer? There's more than, well, no, not really. What one number could the 17 be to make this problem have more to do? It's a tough one. You're the math teacher. What number could be right here instead of 17 to make this problem continuable? No, it's not a terrible idea. If you put a 16 there, then it would say 2x minus 16. And if you pull down 2, you'd have 2 times x minus 8. But unfortunately, the minus 8 doesn't cancel with the plus 8. Do you see that? They're not the same. So you're on the right track. Let's try again. It's a 10. Great job. I'm really glad I gave you guys those extra 20 seconds there. If that were a 10, then the top would say 2x minus 10. So these are the things that I engineer. That's why these things take me forever to write, is because I want sometimes at the end for you to find that piece of fruit. But if that were a 2x minus 10 and you pulled out the 2, then you'd have 2 times x minus 5 and you'd say, aha, x minus 5, I see you. And you'd cancel those out. So again, be hyper vigilant about that. Watch out for progress that could be made. Okay. This is a tough one. I mean, I was going to say not many people have ever answered this correctly, but I think Parker's about to blow our minds. So let's see. Yeah, lots of pressure there, Parker. Ay, Dios mío. What is the least common denominator? You're going to want to say this, and you know that that's not right because I wouldn't give you such an obvious question and then set it up like I did. So it's not x plus 2. It's right in front of you.
That's
Yes, it is. So you're starting to feel the vibe. You're starting to understand that, and this is what the hardest thing in this time of year for me to convince a bunch of 17-year-olds of is this, that this X does not cover this X and vice versa. The reason being that this is a free range X. This one is like, I'm not, dude. I'm bound up in this X plus 2 math problem here. I am not free for you to use me for something else. You understand? And so good job on that, Will. The least common denominator is I need one of these. And unfortunately, I also need one of these. They have nothing to do with each other. One's a part of an addition problem, one is free range. Okay. So having said that, let's go through and do the obligatory question answer session. You're gonna hear me say this a lot. Let's look at the first fraction. What's his bottom missing? Yeah, and I hope more of you knew that than just one person that said it. The question is simply this: how can I make purple thing look like green thing, right? I'm not trying to sound dumb. I'm just saying that's what I'm asking you when I say that. And so you look and say, well, the first fraction's bottom is missing the x plus 2. So we take what's on his top, which is 2x plus 3, and we multiply it by what his bottom needs, which is x plus 2. Good. I'm doing my work formatting a little bit different. I'm going to see if you kind of can pick up this vibe because this is the way we'll start doing them. It's a little bit more efficient. And then I'm going to copy down the minus 3x, and I'm going to ask you the same question again. Second fraction, what is his bottom missing? So we need to multiply him by x. The things that I'm drawing yellow arrows to are the things that the bottoms needed to make the bottoms the same. And that's why we're giving them to the tops. You see, I've completely stopped showing my work on the bottom, right? We know all of this is over the LCD, which is x times x plus 2. And now the rest is just the grind. What is the answer to this red math problem? 3x plus 4x, right? 7x. And then what is the answer to this green math problem? Minus 3x squared. Mhm. And yet another shortcut that I/we will start taking is that I sometimes don't even show the bottom. Once I realize all the grind is on the top of the problem, I sometimes don't even write the bottom until I've committed to like, this is the best version of the top, and then I'll reintroduce the bottom like this. I don't see the sense in keep writing it over x times x plus 2. Then I got all this work to do on top. Let's clean this top. Let's put it in its best order, like the math gods would want us to. Negative 3x squared should always come first. Who goes after that? I'm sorry, that's not negative 3x squared. That's negative 1x squared. Apologies. And how many x's? That's 7x. Keep going. Plus 6. And now I think I want to look at this as over x times x plus 2. Is the top factorable? Yeah, right. And it's close. You got to be real vigilant about this. If you pulled a negative out of the top, it would be negative of x squared minus 7x minus 6. But once you see it as that, you realize you can't factor that down. You're not going to find any numbers that work. So this would be a perfectly wonderful final answer for this problem. I have to show you one more thing now. I'm not going to cover all my examples, but I want to make sure that we get to this. So this will be the last really gnarly. How are you feeling so far, by the way? Kind of middle of the road here. Scale of 1 to 10. 1, cooked. No idea. 10, I'm good. Where are we at? Give me some fingers. How many you got? What is that?
Eight.
8? 8, 9, 10? What are you at? 5? 7?
Negative.
8, 7?
Um,
5, 4? So we're kind of middle of the road. It, Jesse's at the 6 or 7. Good. Attaboy, Jess. Good job. I can't believe you were the first one to say that. So yes, good job. So the last topic, and then there's more, but I'm looking at the clock and he's saying you have 7 minutes, Buster Brown, or 6 minutes, get your poop in a group. So I want to make sure that this one gets out so that you can see it. Um, do you guys all agree with this? If I were to take that and I just said, because I'm in sixth grade, that I could write it like that would be completely bad, right? Are we all clear that you cannot just take a subtraction problem and write it backwards? Okay. Having said that, take a look at this. Would you agree that if I took this 5 minus x and I pulled a -1 out of it, you might say, why would you do that? Well, watch. If I pull a -1 out of something, you know, factor, what does the 5 become?
Negative.
What does the minus x become? And if I write this backwards, look what I just did. Through sheer Harry Potter nonsense wizardry, I just took a 5 minus x and I made it go backwards. The moral of the story is this. If you see something, I don't know, like in the next example that you want to be backwards and it's subtraction, you're going to yank a negative out of it, and that gives you then the right to flip it backwards. Subtraction doesn't turn free of charge, but it can turn if you pull a negative. So for example, if I have a 4 minus x and I want it to be backwards, I can just write it as the negative of x minus 4. What would 3 minus x be? The negative of x minus 3. What would 10 minus x be? The negative of x minus 10. I apologize for that 3. I don't know what happened there. I'm just going to leave it there, though. It can just live on. Hello, Mr. Ugly 3. How about 5 minus 2x? Let's say I wanted that backwards. What would it be? The negative of 2x minus 5. So the fee that you pay is relatively small, but it does exist. So having said that, here's your next example. Probably the last example. We'll see. We're going to do 5 over 3 minus x plus 3x over x minus 3. These are a little bit rough for a while. But we agree we want those denominators to match, right? Like I can't go right now because they're not the same. But if I could make them the same, do we now have a trick up our sleeve that will enable us to do that? Yes, we do. So I look at this and say, what I really want is for you guys both to be the same. So what I'm going to do is I always like the ones with X's first. I could make either of these look like the other, FYI. But I like to take the one that just, by this point in your life, this should just feel backwards to you. It should just feel that way. So I'm going to take that one and I'm going to fix it. And I'm going to rewrite the first fraction as 5 over what? Negative x minus 3. And what I'm going to do now, because anyone with a functioning brain would look at this and say, hey, genius, those denominators are not the same. What I'm going to do to fix that, and you and I were just talking about this like 20 minutes ago, the thing about the negative, why does it distribute to the top and not the bottom? And I told you it can go to the top or the bottom. It just can't go to both. You ready for a trick? I'm going to take the negative like this. Are you ready for this? You ready for some Harry Potter stuff? And I'm going to move it to the top. And now I can get rid of these parentheses. And now are the bottoms the same? Yes, they are. So when you pull the negative, it will behoove you to move the negative up to the top, and then your bottom will be what you want it to be. So what is my final answer to this one? Impressive. You want to try one more of those before we part ways? Got a couple minutes. Let's practice that again. Okay. I'll give you kind of the same problem again, but I'm going to switch it up a little bit. So let's do, I don't know, let's do 6 over x minus 2 minus, I don't know, 3x over 2 minus x. Ready? To operation make the bottoms the same. And I am the guy with the digital pen here, so I'm going to take the bull by the horns and tell you I'm going to switch the one I circled in red. I don't like those backwards ones. So I'm going to switch him. And so I'm going to leave this fraction alone. And what's my new bottom going to be? The red one? Negative parentheses x minus 2. But remember what I said, the bottoms in this state are not the same. What are we going to do with that negative? We're going to move it out to the top. And in this case, the air quotes incoming, the top is actually that sign right there. Ready? So this is what it looks like. It's going to become 6 over x minus 2 plus 3x over x minus 2. Isn't that crazy? Crazy cool, huh? So what's our final answer? Okay, good. Yeah, 3x plus 6 over x minus 2. Could I factor the top? I know you want to get out of here, but answer the question. Can you factor the top? Yes, you can. Will it serve a purpose? Then you don't have to. So the rule of thumb is I don't have to factor if it doesn't bear fruit. In this case, if I pull out the 3, like I know the math gods are poking you to do, I get 3 times x plus 2. And then I'm like, oh, I missed it by that much. So if you were just to leave it like this, you would get no flack from me. Sorry for making you sit through that on this lovely Thursday, but on the other side of it will be work time. So there is Friday school tomorrow. Hooah! So maybe I'll see you for Friday school. Maybe I won't. I hope the rest of your day is lovely.
I will come out.